So, in previous videos, you've learned about the mean value theorem, and recently you've been playing around with these facts here. You've been looking at increasing and decreasing in constant intervals for functions, and I want to show you in this video that these three consequences really come out of the mean value theorem, that these three facts come from the mean value theorem. So I just want to add some connective tissue for you. So again, let's just go over these three things here. I mean, graphically, they're just saying, okay, when our derivative is positive, f is increasing. So maybe we have a function that looks something like this, and we're looking at an interval, looking at a closed interval like this, and we can look at all of these slopes going along it, and you can see that they're positive. So f is increasing. You can see that graphically, and that's what you've been playing with. And similarly, if we have maybe a function that looks like this, and we take a closed interval like this, we can see throughout it that our slopes are negative. Slopes are going to be negative throughout this, and f is decreasing. And then lastly, we have this constant function. Let's see if I can draw a straight line, and our slopes are 0 here. So all of this makes sense to us graphically, but now I want to show you it comes from the mean value theorem. That these facts can be justified using the mean value theorem. And again, the mean value theorem is saying that there exists some c value in our interval from a to b in which the derivative at that c value is equal to the average rate of change. And there are a few things that you need to throw on top of the mean value theorem in order to use it. But let's show that these three facts come from it. So I'm going to manipulate the mean value theorem. I'm going to rewrite it as this. I'm going to multiply both sides by b minus a. So I have f of b minus f of a. F of a is equal to f prime of c times b minus a. Okay? So that's just the mean value theorem rewritten. And what we're assuming here is that b is greater than a, and therefore b minus a is positive. Okay, so now we can go through all these facts. First, let's let f prime of c be positive, and rewriting this now, we have f of b minus f of a is equal to f prime of c times b minus a. And now we're saying this whole right-hand side is positive. So we're saying that f prime of c times b minus a, this whole thing is positive. And therefore, f of b minus f of a is also positive. So then we can just add f of a, and we're left with f of b is greater than f of a. And what this is saying is that f is increasing. Our function is increasing when our derivative is positive for this interval. And that is exactly what we've seen in practice in earlier videos, but you can see it's proven through the mean value theorem. And what we're going to do is just check off the rest of these things now. So we're going to do the same thing with when the derivative is negative. So we're going to let f prime of c be negative now. And same thing, we're going to, maybe we'll skip this first step. So we'll go down here. We'll say that f prime of c times b minus a is less than 0. It's negative. And therefore, f of b minus f of a is also negative. And then we add an f of a over, and we have f of b is less than f of a. And this is what it means for our function to be decreasing. So f is decreasing when our derivative for this interval is negative. So, and lastly, we have one more. We have one more to go. So let's look at when our derivative is constant over an interval. So we're going to let f prime of c be equal to 0 now. Let me grab some more space. And then we're going to say f prime of c times b minus a. This whole thing is now equal to 0. So then we can therefore say that f of b minus f of a is equal to 0. And adding f of a, we have f of b is equal to f of a. So when our derivative is 0 for our interval, our function is constant. F is constant. And really, this isn't adding new information really for you guys. You guys have already seen the mean value theorem and have already worked with increasing, decreasing, and constant intervals. I just wanted to show you that those things really come from the mean value theorem.